point slope form. Problem number 1. Determine the line's equation, its y-intercept, and describe its graph with m equals to -3/5 and point 0 and -6. Okay, so our given, we have a slope which is -3/5, and we have a point. Let's call this as point 1. So this will be point 1 with values of 0 and -6. So since this is point 1, this will be our x sub 1 and -6 will be our y sub 1. Okay. We are going to use the point slope form equation, and that is y minus y sub 1 is equal to the slope, or m, multiplied by x minus x sub 1. So substitute the values. We have y minus y sub 1 is -6 equals to the slope, which is -3/5, multiplied by x minus x sub 1, that is 0. So this will be y negative times negative, that is +6, equals to -3/5 multiplied by x, that's -3/5 x. And -3/5 times -0, this will be 0. So we can cancel this out. Okay. Y will be equal to, so we need to transfer +6 to the other side. So this will be -3/5 x. If we transfer positive to the other side, it will become negative. So this will be -6. So we have here the equation of the form y equals to mx plus b. So our b here, or the y-intercept, that is equal to -6. Our slope again is -3/5. Now, since the slope is negative, okay, since slope is negative, okay, so the line now is going down. So the line is going down. The line is going down from left to right. So the line is going down from left to right. Okay, so this are our final answers. Our equation is y equals to -3/5 x minus 6. Our intercept, or y-intercept, is -6. Our slope is -3/5, and since the slope is negative, the line is going down from left to right. Problem number 2. Determine the line's equation, its y-intercept, and describe its graph with m equals to 3 and point 30. Okay. So our given here, we are given a slope. So we have here a slope which is m, and that is +3. And then another given is a point. So let us call this as point 1 with values of +3 and 0. So 3 here, this will be our x sub 1. 0 is our y sub 1. And then we will use the point slope form equation. So the point slope form equation is y minus y sub 1 equals to the slope multiplied by the quantity of x minus x sub 1. And then substituting the values, we have y minus our y sub 1 is 0, multiply or equals to our slope, which is +3, multiplied by x minus x sub 1, that is +3. So y minus 0, this will be y equals to 3 multiplied by x, that is 3x. and positive 3 multiplied by negative 3, that is negative 9. So this is our equation of the form y equals to mx plus b. Our b now will be negative 9. So b, or the y-intercept, is negative 9. And then again our slope is positive 3. So since our slope is positive, so since slope is positive, so the line is going up. So the line is going up. So the line is going up from left to right. Okay, so again, our equation is y equals to 3x minus 9. Our y-intercept, or b, is negative 9. And since the slope is positive, the line is going up from left to right. Problem number 3. Determine the line's equation, its y-intercept, and describe its graph with m equals to negative 4 and x-intercept equals to negative 3. Okay, so we have here the given. The first given is the slope, or m. So m is equal to negative 4. And the second given is x-intercept. So our x-intercept here, so x-intercept, this is equal to negative 3. So since x-intercept is the only one that is given, this will be x sub 1 equals to negative 3. Okay, let's change that. That will be x sub 1 equals to negative 3. Okay, and then we are going to use the point slope form equation, that is y minus y sub 1 equals to m multiplied by x minus x sub 1. So we have y minus, our y sub 1 is not present, so this will be 0 equals to the slope, which is negative 4. Multiply this by x minus the x-intercept, or x sub 1, that is negative 3. So this will be y equals to negative 4 multiplied by x. So negative times negative will be positive 3. So y is equal to negative 4 times x, that is negative 4x. And negative 4 times positive 3, that is negative 12. So we now have our b here, or the y-intercept. So our b is, our b here is negative 12, our intercept. And our slope is negative 4. So since our slope is negative, okay, so our line now is going down. So line is going down from left to right. From left to right. Okay, so our equation is y equals to negative 4x minus 12. Our intercept is b equals to negative 12, and slope is negative when line is going down from left to right. Point slope form, problem number 1. Determine the line's equation, its y-intercept, and describe its graph with m equals to negative 3 over 5 and point 0 and negative 6. Okay, so our given, we have a slope which is negative 3 over 5, and we have a point. Let's call this as point 1. So this will be point 1 with values of 0 and negative 6. So since this is point 1, this will be our x sub 1 and negative 6 will be our y sub 1. Okay. We are going to use the point slope form equation, and that is y minus y sub 1 is equal to the slope, or m, multiplied by x minus x sub 1. So substitute the values. We have y minus y sub 1 is negative 6 equals to the slope, which is negative 3 over 5 multiplied by x minus x sub 1, that is 0. So this will be y negative times negative, that is positive 6, equals to negative 3 over 5 multiplied by x, that's negative 3 over 5 x. And negative 3 over 5 times negative 0, this will be 0. So we can cancel this out. Y will be equal to, so we need to transfer positive 6 to the other side. So this will be negative 3 over 5 x. If we transfer positive to the other side, it will become negative. So this will be negative 6. So we have here the equation of the form y equals to mx plus b. So our b here, or the y-intercept, that is equal to negative 6. Our slope again is negative 3 over 5. Now, since the slope is negative, okay, since slope is negative, okay, so the line now is going down. So the line is going down. The line is going down from left to right. So the line is going down from left to right. Okay, so this are our final answers. Our equation is y equals to negative 3 over 5x minus 6. Our intercept, or y-intercept, is negative 6. Our slope is negative 3 over 5, and since the slope is negative, the line is going down from left to right. Problem number 2. Determine the line's equation, its y-intercept, and describe its graph with m equals to 3 and 0.30. Okay. So our given here, we are given a slope. So we have here a slope which is m, and that is positive 3. And then another given is a point. So let us call this as point 1 with values of positive 3 and 0. So 3 here, this will be our x sub 1. 0 is our y sub 1. And then we will use the point slope form equation. So the point slope form equation is y minus y sub 1 equals to the slope multiplied by the quantity of x minus x sub 1. And then substituting the values, we have y minus our y sub 1 is 0 multiply or equals to our slope, which is positive 3, multiplied by x minus x sub 1, that is positive 3. So y minus 0, this will be y equals to 3 multiplied by x, that is 3x. And positive 3 multiplied by negative 3, that is negative 9. So this is our equation of the form y equals to mx plus b. Our b now will be negative 9. So b, or the y-intercept, is negative 9. And then again, our slope is positive 3. So since our slope, Okay, slope is positive. Okay, so since slope is positive, so the line is going up. So the line is going up. So the line is going up from left to right. Okay, so again, our equation is y equals to 3x minus 9. Our y-intercept or b is negative 9. And since the slope is positive, the line is going up from left to right. Problem number 3. Determine the line's equation, its y-intercept, and describe its graph with m equals to negative 4 and x-intercept equals to negative 3. Okay, so we have here the given. The first given is the slope or m. So m is equal to negative 4. And the second given is x-intercept. So our x-intercept here, so x-intercept, this is equal to negative 3. So since x-intercept is the only one that is given, this will be x sub 1 equals to negative 3. Okay, let's change that. That will be x sub 1 equals to negative 3. Okay, and then we are going to use the point slope form equation. That is y minus y sub 1 equals to m multiplied by x minus x sub 1. So we have y minus, our y sub 1 is not present, so this will be 0 equals to the slope, which is negative 4. Multiply this by x minus the x-intercept or x sub 1, that is negative 3. So this will be y equals to negative 4 multiplied by x. So negative times negative will be positive 3. So y is equal to negative 4 times x, that is negative 4x. And negative 4 times positive 3, that is negative 12. So we now have our b here, or the y-intercept. So our b is, our b here is negative 12, our intercept. And our slope is negative 4. So since our slope is negative, okay, so our line now is going down. So line is going down from left to right. From left to right. Okay, so our equation is y equals to negative 4x minus 12. Our intercept is b equals to negative 12, and slope is negative when line is going down from left to right. Slope of a line, slope formula. Problem number 1. Find the slope of a line passing through points positive 2 and negative 3 and point positive 7 and positive 8. First, we need to find the values of the first and the second x and y. So for our point 1, positive 2 here, this will be our x sub 1. And negative 3 is our y sub 1. For our point 2, positive 7 is the x sub 2 and positive 8 is the y sub 2. And then we can now solve for the value of the slope. So the formula for the slope is m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x. Or rather, that is minus, that's minus x sub 1. And then we will just substitute the given. Our y sub 2 is positive 8 minus y sub 1, which is negative 3. So this is negative 3. All over our x sub 2, that is positive 7 minus x sub 1, which is positive 2. So this will be 8 negative and negative, that will become positive, and 7 minus 2 is 5. So our slope now, which is m, will be equal to 8 plus 3 is 11 divided by 5. So the answer for number 1 for our slope is positive 11 all over 5. Number 2. Find the slope of a line passing through points 0 and negative 2 and point negative 8 and positive 5. Again, we need first to find the values of x and y's of the 2 points. So on our first point, 0 here, this is our x sub 1. Negative 2 is our y sub 1. And negative 8, this is our x sub 2. And positive 5 is our y sub 2. And then we can use the slope formula, which is m equals to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Our value for y sub 2, that is positive 5. And minus that with y sub 1. Our y sub 1 is negative 2. Divided by x sub 2, which is negative 8, minus x sub 1, which is 0. So this will be 5 minus times negative, that will be positive now. So y, or rather 5 plus 2 all over negative 8 minus 0, that is negative 8. So our slope now will be positive 7 all over negative 8. So our slope for our second problem is positive 7 all over negative 8. Problem number 3. Find the slope of a line passing through positive points positive 4 and 4 and point negative 9 and positive 4. Let us identify the values of x and y on the 2 points. On our first point, positive 4, this is x sub 1. And another positive 4, this is y sub 1. On the second point, negative 9 is our x sub 2. And positive 4 is our y sub 2. We can then use the slope formula. Again, that is m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Again, just substitute the values. So y sub 2, that is positive 4, minus y sub 1, that is positive 4. All over x sub 2, that's negative 9, minus x sub 1, which is positive 4. So this will be 4 minus 4 is 0, all over negative 9 minus 4, that is negative 13. But we know that any number, or 0 divided by any number, the answer is 0. So our slope for problem number 3 is 0. So we do not have a slope for problem number 3. Problem number 4. Find the slope of a line passing through points positive 7 and positive 8 and point positive 2 and negative 3. So again, let us identify the values of x sub 1 and y sub 1 and x sub 2, y sub 2. So positive 7, this is our x sub 1. Positive 8 is our y sub 1. Positive 2, this is our x sub 2. And negative 3 is our y sub 2. And then we are now going to solve for the slope of a line using the slope formula, that is m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Our y sub 2, that is equal to negative 3 minus y sub 1, which is positive 8, all over x sub 2, that is positive 2 minus x sub 1, that is positive 7. So negative 3 minus 8, that is negative 11, all over 2 minus 7, that will give us negative 2 minus 7, that will give us negative 5 rather. So negative 5. Our slope now will be negative divided by negative, that will become positive. So our slope here will be 11 all over 5. So positive 11 all over 5 is the slope of problem number 4. Problem number 5. Find the slope of a line passing through point positive 3 and 7 and point negative 5 and positive 9. Again, we are going to find the values of x sub 1 and y sub 1 and x sub 2 and y sub 2. So our 3 here, this will be the value for x sub 1. Our 7 is the value for y sub 1. Negative 5, that is the value for x sub 2. And positive 9 is the value for y sub 2. We are then going to use the slope formula. The slope formula is m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So the value for y sub 2, that is positive 9, minus the value for y sub 1, which is positive 7, divided by x sub 2, that is negative 5, minus the value of x sub 1, which is positive 3. 9 minus 7, that is positive 2, divided by negative 5 minus 3, that will give us negative 8. So our slope here will be 2 all over 8. This can be simplified. So 2 is common between the numerator and the denominator. So 2 divided by 2 is 1, and 8 divided by 2 is 4, and the sign is negative. So our slope for problem number 5 is negative 1 all over 4. Problem number 6. Find the x-coordinate of the second point if the slope of the line containing the points 4 and 2 and x and 10 is equal to 4. Okay, so we have here 2 points and a slope. Okay, so for point 1, we have, okay, let's call this as point 1. So our point 1, we have positive 4 and positive 2. For point 2, so our point 2, we have x, which is the unknown, and positive 10. So let us identify the x sub 1, y sub 1, and x sub 2, and y sub 2. Okay, so since this is our point 1, so positive 4 and positive 2. So since this is point 1, so positive 4 will be x sub 1, and positive 2 will be y sub 1. For point 2, x, this will be x sub 2, so it is the unknown, and 10 will be y sub 2. Okay, so let us now solve for the value of x sub 2. So our m here, so let's not forget the m or the slope. The m is positive 4. Okay. So the formula now, The formula for slope, again, that is m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And then we are going to substitute the values. For m, we have 4 equals 2. Our y sub 2, what is our y sub 2? That is positive 10 minus y sub 1, that is positive 2. And then our x sub 2 is x minus x sub 1, which is positive 4. Okay. So by cross multiplication, so we are going to cross multiply. So this will be 4 multiplied by the quantity of x minus 4, and since this is considered as 1, so 10 minus 2 will remain here. 10 minus 2. So this will be 4x minus 16 equals to 10 minus 2, that is positive 8. So transpose negative 16 to the other side. So what will be left here is 4x equals to 8 plus 16. Okay. So 4x here will be equal to, that is 24. And to find 4x, you have to cancel out 4. So divide both sides of the equation by 4. So our x here will be equal to 24 divided by 4, or that will give us positive 6. So therefore, our x sub 2 is equal to 6. Problem number 7. Find the y-coordinate of the second point if the slope of the line containing the points positive 4 and positive 4 and point positive 6 and y is equal to 4. So again, let us first write down the values of the 2 points. So for point 1, we have positive 4 and positive 4. And for point 2, we have 6 and the unknown, which is y. And then we are going to identify x sub 1, x sub 2, y sub 1, y sub 2. So on the first point, positive 4, this is our x sub 1. And the second positive 4, that is our y sub 1. Positive 6, this is our x sub 2, and y is our y sub 2. So our unknown is y sub 2. So to solve for y sub 2, the formula now for slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Our y sub 2, that is the unknown, so let's represent that as y minus y sub 1, that is 4, all over x sub 2, that is positive 6, minus x sub 1, which is positive 4. And let us not forget that our slope is equal to 4. So m here will be equal to 4. And then by cross multiplication, we can multiply 4 and the quantity 6 minus 4. So this will be 4 multiplied by 6 minus 4 equals to y minus 4. So this will be 4 times 2 equals to y minus 4. So our y here will be equal to 4 times 2, that is 8. And then we will transpose negative 4 to the other side. This will become positive 4. So our 8, or rather our y will be 8 plus 4, and that is 12. So y here, this is y sub 2. So our value for y sub 2 is positive 12. Solving quadratic equations by factoring. Our first problem, we have x squared minus 6x plus 8 equals to 0. So to solve this quadratic equation by factoring, first let us find out if there is a numerical coefficient or number before x. So since there is no number before x, we will base our factoring on the last term, which is positive 8. Okay, so what we are going to do, we are going to have here two sets. Okay, and then equate this to 0. Now we will find two numbers, or we will find factors of positive 8. So these two numbers, when they are multiplied by themselves, it will give us a product of positive 8. And then make sure that these two numbers will give us a sum of negative 6x or negative 6. Okay, so let us think of those two numbers. Now, since this is negative, the two numbers must also be negative. So let us put here their sign, negative, negative. Okay, so what are the two numbers that are factors of positive 8? So this will be, let's try 4 or negative 4 and negative 2. Okay, now let us check. Negative 4 multiplied by negative 2 is positive 8. Okay, that is correct. And negative 4 plus negative 2, that is negative 6. So we now have the factors of 8, which is negative 4 and negative 2. So the lacking terms here, we are just going to factor out x squared. So the factors of x squared will only be x and x. So these are the two factors now for our equation. So to find for the values of x, there will be two values. So the first one will be x minus 4 equals to 0, and the second one will be x minus 2 equals to 0. So to find for the value of the first x, we will just transpose or transfer negative 4 to the other side. So if we transpose negative 4 from negative, it will change its sign. So what will be left on the left side will now be positive x. And if we transpose this to the other side, it will change its sign. It will become positive 4. So our x sub 1 here is positive 4. Okay, so our x sub 2, or the second value of x, again, we will transpose negative 2 to the other side. So what will be left on the left side will now be positive x. And then if we transpose negative to the other side, it will change sign. So this will become positive 2. So our x sub 2 is positive 2. So therefore, x sub 1 equals to positive 4 and x sub 2 equals to positive 2. They are our final answers. Next problem. Our next problem is x squared minus 8x plus 15 equals to 0. So to factor out this quadratic equation, first let us see if there is no numerical coefficient or no number before our x squared. So there is no number here before our x squared. So since there is no number, we will start basing our factoring on the last term. Our last term is positive 15. Okay, so we will have two sets here. And then equate this to 0. So we will have here the last numbers. So the last numbers will be the factors of positive 15. So meaning to say they are two numbers that will give us a product of positive 15. And then their sum will give us, when we add the two, it will give us the sum of negative 8. Okay, now since this is negative 8 and this is positive 15, it is safe to say that the two numbers will be both negative. Okay, so let us now think of the two numbers that are factors of positive 15. So let's try 5 and 3. So we have here negative 5 and negative 3. Let us check. Negative 5 multiplied by negative 3, positive 15. So that is correct. Negative 5 plus negative 3, negative 8. So these two numbers are correct. And then we will just factor out x squared. So the factors of x squared, they are just x multiplied by x. So we have now the two factors. Let us find for the values of x. So the first value of x will be x minus 5 equal to 0. And the second value will be x minus 3 equals to 0. So to find for the value of the first x, or x sub 1, we need to transpose or transfer negative 5 to the other side. If we transpose negative 5, what will be left on the left side will be x. And if we transpose negative to the other side, this will change sign. This will become positive. So this will be positive 5. So our x sub 1 is positive 5. And then to solve for x sub 2, we will just transpose negative 3 to the other side. So if we transpose negative 3, what will be left here will be positive x. And if we transpose negative, this will change sign, it will become positive. So negative 3 will become positive 3, and this is our x sub 2. So therefore, x sub 1 equals to positive 5, and x sub 2 equals to positive 3. They are our final answers. Our next problem, we have positive 6x squared plus 17x minus 14 equals to 0. Since our first term has a numerical coefficient, so we will base our factoring on our first term. Okay, so we will factor out our first term. This is equal to 0. So our first term is 6x squared. So the factors of 6x squared, we have positive 3x and positive 2x. And then let us factor out our last term. Our last term is negative 14. So since this is negative, the factors of negative 14 will be negative and positive. Okay. So the factors of negative 14, let's try negative 2 and positive 7. So negative 2 times positive 7 is negative 14. But let us check if we can arrive with the sum of positive 17x. Okay, so let us check if we can arrive with the sum. So to find the sum, we will get the product. Okay, the product of the outside and the inside terms. Okay, so we have positive 3x multiplied by positive 7, we have positive 21x. And then we have negative 2 multiplied by positive 2x, negative 4x. So 21x minus 4x, this will give us 17x. So therefore, 17x is equal to our second term here. So we are going to use these two factors. Okay, so let us now erase this, since these are now the two factors that we are going to use. Okay, so we are now going to solve for the two values of x. So we have here 3x minus 2 equals to 0, and 2x plus 7 equals to 0. So to solve for x here, first we need to transpose negative 2 to the other side. So transposing, we will have, okay, so what will be left on the left side will only be positive 3x. And if we transpose negative, this will change sign. This will become positive 2. To solve for x, we need to cancel out 3. So we need to divide both sides of the equation by 3. 3 divided by 3, we can cancel this out since this is equal to 1. 1 multiplied by x, that is equal to 3x. And our x here is equal to 2 over 3. This will be our x sub 1. Okay. So let us solve for our x sub 2. So to solve for x sub 2, we need to transpose again positive 7 to the other side. So what will be left on the left side will only be positive 2x, and if we transpose positive, this will change sign. This will become negative 7. And to solve for x, we need to cancel out 2 here. So to cancel 2, divide both sides of the equation by 2. So 2 divided by 2, this will be equal to positive 1. So cancel that out. Okay. So 1 multiplied by x, this is equal to x. And negative 7 divided by 2, so negative. Okay, we can simplify this to mix fractions. So this will be negative 3 and 1/2. Okay, so our x sub 2 is negative 3 and 1/2. Therefore, x sub 1 equals to positive 2 over 3, and x sub 2 equals to negative 3 and 1/2 are our final answers. Our next problem, we have positive 12a squared minus 28a minus 49 equals to 0. So to solve this quadratic equation using the factoring, so since our first term here has a numerical coefficient before a squared, so we are going to first base our factoring on the first term. So there will be 2 sets of factors, and this is equal to 0. So the factor of 12a squared, okay, so let us use the factors. Its factors will be 6a multiplied by 2a. So let us check. 6a multiplied by 2a, that is equal to positive 12a squared. So we can use those factors. Okay. And then we are going to factor out our third term. Our third term is negative 49. And then our third term here has a negative sign, and our second term has a negative sign. So what we are going to do with this is that we need to choose 2 numbers wherein the larger number will be negative, since our second term here is negative. Okay, so let us put here the factors. But the factors of 49, they are only negative 7 and positive 7. Okay, so we are going to put negative 7, okay, on our outside term so that it will be multiplied by 6a. So it will be bigger than the inside terms. So we are going to have here positive 7. So positive 7 multiplied by negative 7 is negative 49. And then let us check if the sum of the outside terms and the inside terms is equal to negative 28a. Okay, so let's get their sum. we have here negative 7 multiplied by positive 6a. This will be equal to negative 42a. And then positive 2a times positive 7, this will be positive 14a. So this will be equal to negative 42a plus positive 14a. This is negative 28a. So therefore, our two factors here are correct since negative 28a is equal to our second term. Okay, so we can erase this one. Okay, since these two factors now are correct, we can now proceed to solving the values of a. Okay, let's erase this first. Now, to solve for the value of a, we have here 6a plus 7 equals to 0, and we have here 2a minus 7 equals to 0. So to solve for a, we need to transpose positive 7 to the other side. So positive 7, transpose that to the other side. So transposing, what will be left on the left side will be positive 6a. And if we transpose positive, it will change sign. This will become negative 7. So to solve for a, we need to cancel out 6. So divide both sides of the equation by 6. So we have here 6 divided by 6. Cancel that out. That is equal to 1. And 1 multiplied by a, this is equal to a. And negative 7 over 6. So this is our a sub 1. And this is equal to negative 1 and 1 over 6. Okay, so let us now solve for a sub 2. So to solve for a sub 2, first we need to transpose negative 7 to the other side. So if we transpose, what will be left on the left side will be positive 2a. Excuse. So we have here positive 2a. If we transpose this, this will become positive 7. So to solve for the value of a, we need to divide both sides of the equation by 2. So we have here 2 divided by 2. This is equal to 1. Okay. So 1 multiplied by a, this will give us positive a, and positive 7 over 2, or this is equal to 3 and 1 over 2. So this is our a sub 2. So this now are our final answers. Our next problem, we have positive 2b squared plus 2b minus 4 equals to 0. Now, since we have here a numerical coefficient before b squared, so we are going to base our factor first on our first term. Okay, so we will have here two sets of factors, and this will be equal to 0. So we are going to factor out positive 2b squared. So the factors of 2b squared, we have positive 2b. So positive 2b multiplied by b. And then next we are going to factor out our third term. Our third term here is negative 4. So since this is negative and our middle term or our second term is positive, so the factors that we are going to use with negative 4 will be positive and negative. Okay, so let's put here negative and positive. Now, since this is positive 2b, okay, so we are going to put the positive side of 2 on the side, and the negative will be here. And then let us check if the sum of the outside terms. So this will be the outside terms. If there's sum of the outside and the inside term will be equal to positive 2b, then these are the correct factors. Okay, so let us check. 2b multiplied by positive 2, that is equal to positive 4b. And then b multiplied by negative 2, that is negative 2b. So 4b minus 2b, this is equal to positive 2b. Now, since our 2b here is equal to positive 2b, so we can say that these are now the correct factors. So we can now proceed to solving the values of b. So there will be two values for b, b sub 1 and b sub 2. Okay. So to find for b sub 1, we will have here 2b minus 2 equals to 0. And to find for b sub 2, we have b plus 2 equals to 0. So to solve for b, first we need to transpose negative 2 to the other side. So transpose that. So transposing, what will be left on the left side will be positive 2b equals 2. If we transpose negative, this will change sign, this will become positive. And to solve for v, we need to cancel out 2. So to cancel out 2, just divide both sides of the equation by 2. Now, 2 divided by 2, this will be cancelled out since this is equal to 1. And then 1 multiplied by b, this will give us positive b. 2 divided by 2 is positive 1. So this will be our b sub 1. Now, to find for b sub 2, we need to transpose positive 2 to the other side. So transpose that to the other side. So if we transpose, okay, what will be left on the left side will be positive b. And if we transpose this, it will change its sign. So from positive, this will become negative 2. And this is our b sub 2. So therefore, our b sub 1 is positive 1 and our b sub 2 is negative 2. These are our final answers. Solving quadratic equations by completing the squares. Our problem. Okay, here's our problem. Y squared minus 4y equals to positive 21. To solve this quadratic equation by completing the square, first let us find, we have to make sure that there is no numerical coefficient between our first term. So in this equation, there is no numerical coefficient, so we can proceed in completing the squares. Okay, so again, this is y squared minus 4y. To complete the square, we have to put here the plus sign, and then there will be a term here. We are going to add a term. Now the numerator will be the numerical coefficient of the second term. So we will copy the numerical coefficient, that is 4. And then the numerator will be divided by a constant, and that is positive 2. And then we are going to raise this quantity by 2. So whatever is added on the left side must also be added on the right side. So we have here 21, and then we are going to add 4 divided by 2 raised to the power of 2. And then we have here y squared minus 4y plus 4 divided by 2, that is equal to 2. So this will be 2 raised to the power of 2 equals to 21 plus 4 divided by 2 is 2, so this will be 2 raised to the power of 2. Okay, so y squared minus 4y plus 2 raised to the power of 2 is 4. This will be equal to 21 plus 4. So y squared minus 4y plus 4, this is now a perfect square. So our first term here will be y, and since this is negative, we will also have here the negative sign, and the square root of 4 will be 2. So since this is a perfect square, we will just raise this quantity into 2. And then 21 plus 4 is 25. Now, we are going to get the square root of both sides. So, get the square root of both sides. Okay. So, we will have here the quantity of y minus 2 raised to the power of 2 equals to the square root of 25. Okay. So the square root of the quantity y minus 2 raised to the power of 2, that is equal to the quantity of y minus 2. And the square root of 25 will be plus minus 5. Okay. So to find for y, we will have here y minus 2 equals to plus minus 5. So we need to transpose negative 2 to the other side. So transposing negative 2 will be transposed there to the other side. So transposing, what will be left on the left side will be positive y, and we will have here plus minus 5. If we transpose negative, this will change sign. It will become positive. Okay, so there will be two values for y. Okay, the first value will be the positive 5. So this will be positive 5 plus 2. And the second value for y will be the negative 5. So this will be negative 5 plus 2. Okay. So this will be our y sub 1. 5 plus 2 is 7. And this will be our y sub 2. And it is negative 5 plus 2, that is negative 3. So therefore, y sub 1 equals to positive 7, y sub 2 equals to negative 3. They are our final answers. Solving quadratic equations by completing the squares. Our next problem, we have x squared plus 6x equals to positive 7. To solve quadratic equations by completing the squares, first let us check if we have a numerical coefficient before the first term. Okay, so we have no numerical coefficient before the first term. Let us now proceed. So this will be x squared plus 6x. Okay, so to complete the square, we need to add here the third term, a third term, and this third term will be a fraction. So the numerator will be the numerical coefficient of our second term, so that is positive 6. And the denominator will be a constant 2. This will be raised to the power of 2. Okay. Now, whatever is added on the left side must also be added on the right side, so as not to change our equation. So this will be plus 6 over 2 raised to the power of 2. Okay, so x squared plus 6x plus 6 divided by 2 is 3. So this will be 3 raised to the power of 2, and this will be equal to 7 plus 6 divided by 2, that is 3 raised to the power of 2. So we have here x squared plus 6x plus 3 raised to the power of 2, that is positive 9. This will be equal to 7 plus 9. So x squared plus 6x plus 9, this is already a perfect square. Okay, so to factor this out as a perfect square, x here, the factor of x squared is x, and then since this is positive, we will have here the positive sign also, and then the factors of positive 9 is positive 3. And then since this is a perfect square, we need to raise that to the power of 2. And 7 plus 9 is 16. Now, to remove this perfect square, we need to get the square root. Okay, we need to get the square root of both sides. So this will be the square root of the quantity of x plus 3 raised to the power of 2. Okay, let's change the color of that. So that will be the quantity of x plus 3 raised to the power of 2, and this will also be the square root. Okay, so we are going to get also the square root. So this will be now the square root of 16. Okay, so the square root of the quantity of x plus 3 raised to the power of 2, this will be equal to x plus 3. So this will now be x plus 3, and the square root of positive 16 is plus minus 4. Now, to find for the value of x, we need to transpose positive 3. So we need to transpose this or transfer that to the other side. If we transpose positive 3, what will be left here will only be x. Okay, so we have here plus minus 4, and if we transpose positive, this will change sign. This will become negative. So we will have now two values for x. Our first value will be x plus 4 minus 3, and our second value will be x is equal to negative 4 minus 3. So x here will be equal to 4 minus 3, this is positive 1, and this is our x sub 1. Our x sub 2 will be equal to negative 4 minus 3, that is negative 7. So therefore, x sub 1 equals to positive 1, and x sub 2 equals to negative 7. They are our final answers. Solving quadratic equations by completing the squares. Our next problem, we will have x squared plus 20x minus 44 equals to 0. So to solve for the quadratic equations by completing the square, make sure that there is no numerical coefficient before the first term. Okay, in this equation there is no numerical coefficient before the first term. We can now proceed. We have here x squared plus 20x. Okay, we need to transpose negative 44. We need to transpose the last term. So our last term here is negative 44. So we need to transpose that to the other side. So transposing, what will be left here will be x squared plus 20x. And if we transpose negative, this will change sign. This will become positive 44. Okay. Now, we need to put here a new third term, and this will be, we are going to add. So our new term will be a fraction. Okay. The numerator will be the numerical coefficient of our second term, that is positive 20. And the denominator is a constant 2. And then raise this to the power of 2. Now, whatever is added on the left side must also be added on the right side so as not to change our equation. We will have here 20 divided by 2 raised to the power of 2. So x squared plus 20x plus 20 divided by 2 is 10. So we have here 10 raised to the power of 2. 44 plus 20 divided by 2, that is 10 raised to the power of 2. Now x squared plus 20x plus 10 raised to 2, that will be equal to 100. So x squared plus 20x plus 10 raised to the power of 2, that is 100. And then we will have here 44 plus 100. X squared plus 20x plus 100. This is a perfect square. Okay, so we can factor this out. The factor of x squared will be x, and then since this is positive, we'll also have here positive. And the factor of 100, this is a perfect square, its perfect square will be 10. And then again, since this is a perfect square, we need to raise this quantity to the power of 2. 44 plus 100, this will give us 144. And then to eliminate the square or the power of 2 sign here, we need to get the square root of both sides. So we will have here the square root, and on the right side we will also get the square root. So this will be the square root of x plus 10 raised to the power of 2, and this will also be the square root of 144. Now, the square root of the quantity of x plus 10 raised to the power of 2, that will be equal to x plus 10. Okay, so this will be equal to x plus 10. Okay, and then the square root now, the square root of 144, this will give us plus minus 12. So to find for the two values of x, first we need to transpose positive 10 to the other side. So transpose positive 10 to the other side. When we transpose positive 10, what will be left on the left side will only be positive x. And we will have here plus minus 12. If we transpose positive, this will change sign, this will become negative. So this will be negative 10. Now, to solve for the first value of x, our first value of x or x sub 1 will be the positive 12. So this will be positive 12 minus 10. And to solve for x sub 2, we are going to use the negative. So this will be negative 12 minus 10. So our x sub 1 here will be equal to positive 12 minus 10, that is positive 2. And our x sub 2 will be negative 12 minus 10, negative 22. So therefore, x sub 1 equals to positive 2 and x sub 2 equals to negative 22. They are our final answers. Solving quadratic equations by completing the squares. Our next problem, we have y squared plus 8y plus 7 equals to 0. So to solve quadratic equations by completing the squares, make sure that there is no numerical coefficient before our first term. So since there is none, we can now proceed. So first, we need to transpose the last term of our equation to the other side. So we need to transpose positive 7 to the right side. What will be left on the left side will only be y squared plus 8y. This will be equal to 0. Now, if we transpose positive to the other side, this will change sign. So no need to write here 0. So from positive, this will change sign. This will now become negative 7. And then we need to add a new term on the left side. So this will be added. The term here will be a fraction. The numerator will be the numerical coefficient of our second term, that is positive 8. And the denominator will be a constant number, and that is 2. So this term will be raised to the power of 2. Now take note, whatever is added on the left side must also be added on the right side so that our equation will not be changed. 8 plus 2 raised to the power of 2. Y squared plus 8y plus 8 divided by 2 is 4. this will be 4 raised to the power of 2, and this will be negative 7 plus 4 raised to the power of 2. Y squared plus 8y plus 4 raised to the power of 2 is 16 equals to negative 7 plus 16. Y squared plus 8y plus 16. This is already a perfect square. So to factor this out, the factor of y squared as a perfect square will be y, and since this is positive, this will also be addition, and the factors of positive 16 as a perfect square is 4. And then raise the quantity to the power of 2. Negative 16, or rather negative 7 plus 16 is positive 9. And to remove the power of 2 here, we need to get the square root of both sides. So we will get the square root of this side as well as this side. This will now be the square root of the quantity y plus 4 raised to the power of 2 equals to the square root of positive 9. Okay, let's just make this a little longer. And then the square root now of y plus 4 raised to the power of 2. The square root of y plus 4 raised to the power of 2 will now be y plus 4, and the square root of 9 will be plus minus 3. To solve for y, we need again to transpose positive 4 to the other side. So transpose that to the other side. What will be left on the left side will only be positive y, and we have here plus minus 3. If we transpose positive 4, this will change sign. This will become negative 4. So there will be two values of y. We will have here first the positive, so positive 3 minus 4, and the second value will be the negative 3 minus 4. So our y sub 1 here will be 3 minus 4, that is negative 1. And our y sub 2 will be negative 3 minus 4, negative 7. So therefore, y sub 1 equals to negative 1 and y sub 2 equals to negative 7. They are our final answers. Solving quadratic equations by completing the squares. Our next problem, we have a squared minus 12a equals to negative 28. First, let us check if there is a numerical coefficient before a squared. Okay, so since there is none, we can proceed. Now, a squared minus 12a, we will have here a third term in order to complete the square. So our third term here will be added, and our third term will be a fraction. So the numerator will be the numerical coefficient, and that is 12. Disregard the sign, okay? And our denominator will be the number 2. So the number 2 is constant. So we have here plus 12 divided by 2, and then this term will be raised to the power of 2. Now remember, whatever is added on the left side must also be added on the right side, so as not to change the equation. So this will also be plus 12 divided by 2 raised to the power of 2. A squared minus 12a plus 12 divided by 2 is 6 raised to the power of 2. Negative 28 plus 6 raised to the power of 2. So a squared minus 12a plus 36, this will be equal to negative 28 plus 36. a squared minus 12a plus 36 is a perfect square. So since this is a perfect square, the factor now will be the factor of a squared, and that will be a. And since this is minus, we are going also to subtract. So our next term will be the factor, or the square root of 36, and that is equal to 6. Now, since this is a perfect square, we are going to raise this quantity into a power of 2, and then negative 28. Okay, negative 28 plus 36 will be positive 8. And then to get this power of 2, to remove that, we need to get the square root of both sides of the equation. So this will be the square root and the square root here on the right side. So this will be the square root of the quantity of a minus 6 raised to the power of 2 equals to the square root of 8. Now, the square root of a minus 6 raised to the power of 2, that will be equal to a minus 6. So we are now going to have here a minus 6. This will be equal to plus minus the square root of 8. Now we can simplify 8. Okay, so we will have here a minus 6 equals to plus minus. So the factors of 8 will be 4 and 2. So this will be 4 times 2. So we will have here a minus 6 is equal to plus minus the square root of 4 is 2. And we will have here the square root of 2. Now to find for a, we need to transpose negative 6 to the other side. So transpose that to the other side. Transposing, what will be left on the left side will be positive a, and we will have here plus minus 2 square root of 2. If we transpose negative, this will change sign, this will become positive 6. So to find for a, there will be two values. The first one will be the positive 2, so this will be positive 2 square root of 2 plus 6. And our next value for a will be the negative, so this will be minus 2 square root of 2 plus 6. Okay, so we can rearrange this. This will be our a sub 1. So this will be 6 plus 2 square root of 2. And this will be our a sub 2. And this will be 6 minus 2 square root of 2. And these are now our final answers. Solving quadratic equations by completing the squares. Our next problem, we have a squared minus 10a equals to negative 7. To solve for the value of a, we need first to identify if this quadratic equation has a numerical coefficient on the first term. Since there is none, we can proceed. So we will have here a squared minus 10a. Now, we will add a third term to make this as a perfect square. So we will add here, the term will be a fraction. The numerator will be the numerical coefficient of the second term, disregarding the sign. So this will be positive 10, and the denominator will be a constant number 2. This term will be raised to the power of 2. And then take note, whatever is added on the right side must also be added on the, or whatever is added on the left side must also be added on the right side. So we also have here plus 10 over 2 divided by 2. A squared minus 10a plus 10 divided by 2 is 5. This will be 5 raised to the power of 2 equals to negative 7 plus 5 raised to the power of 2. We will have here a squared minus 10a plus 5 raised to the power of 2 is 25, and this will be negative 7 plus 5 raised to the power of 2 is 25. A squared minus 10a plus 25 is a perfect square. So the factor here will be a, and since this is negative, we will also have here minus sign, and the square of 25 will be 5. So this quantity here will be raised to the power of 2 since this is a perfect square. And then we have here negative 7 plus 25, this will be positive 18. Okay, so to get rid of the square, we need to get the square root of both sides. So we will have here the square root on the left and the square root on the right. Okay, so we are going to have here the square root of the quantity a minus 5 raised to the power of 2 equals to the square root of 18. Now the square root of a minus 5 raised to the power of 2, that will be equal to a minus 5. So this will be a minus 5 equals to the square root of 18 is plus minus the square root of 18. We can simplify 18, so this will be a minus 5 equals to plus minus the square root of 18. The factors of 18 will be 9 times 2. Okay, now to find for the value of a, we need to transpose negative 5 to the other side. So transpose that to the other side. What will be left? On the left side will only be positive a. This is equal to plus minus the square root of 9 is 3. So this will be plus minus 3 square root of 2. If we transpose negative, this will change sign, so this will now become positive 5. So our a sub 1 here will be the positive 3, so this will be positive, okay, that will be positive 3 square root of 2. So again, our a sub 1 will be 3 square root of 2 plus 5, and our a sub 2 will be the negative 3 square root of 2 plus 5. So we can rearrange this. This will be 5 plus 3 square root of 2, or a sub 2 here will be 5 minus 3 square root of 2. So these are now our final answers. Solving quadratic equations by completing the squares. Next problem, we have positive 2b squared minus 12b equals to negative 14. So since we have here a numerical coefficient, first we need to cancel this out. So to cancel this out, we are going to divide both sides of the equation by 2. Okay, so 2b squared times 1/2, that will be 2b squared divided by 2. So this will be 2b squared all over 2 minus 12b times 1/2, that will be minus 12b all over 2. And this will be equal to negative 14 times 1/2, that will be negative 14 divided by 2. So 2 divided by 2, we can cancel this out. This will be equal to 1. 12 divided by 2, cancel that out. This is equal to 6. And negative 14 divided by 2, this is 7. Okay, so we have here 1 multiplied by b squared. This will give us positive b squared minus 6 times b, that is 6b, equals to negative 7. Okay, we now have no numerical coefficient on the first term. We can now proceed on completing the squares. We have here b squared minus 6b. So in order to complete the square, we are going to add the third term here, and the third term is a fraction. Our numerator will be the numerical coefficient of the second term disregarding the sign, so this will be 6. Our denominator will be a constant number 2. And then this term or this quantity will be raised to the power of 2. And again, take note, whatever is added on the left must also be added on the right side so as not to change the equation. So this will still be plus 6 all over 2 divided by 2. So we have here b squared minus 6b plus 3 divided by 2, or rather 6 divided by 2 is 3. 3 raised to the power of 2 is 9. So this will be negative plus 9. Okay. So b squared minus 6b plus 9 is a perfect square. So this will be b, and since this is negative, this will also be minus sign, and the square root of 9 is 3. So since this is a perfect square, we are going to raise this quantity into 2. Now, negative 7 plus 9, this will give us positive 2. Okay, so b minus 3 raised to the power of 2 equals 2. To eliminate this exponent, we need to get the square root of both sides. So this will be the square root of b minus 3 raised to the power of 2 equals to the square root of 2. The square root of this quantity b minus 3 raised to power of 2 will now be b minus 3 equals 2 plus minus. We cannot simplify this anymore, so this will be plus minus square root of 2. Now, to find for b, we need to transfer out transpose negative 3 to the other side. So transposing, what will be left on the left side will now only be positive b, and this will be plus minus square root of 2. If we transpose negative, this will change sign. This will now become positive 3. So our b sub 1 here will be the positive. So this will be the positive square root of 2 plus 3. And our b sub 2 will be the negative. So this will be negative square root of 2 plus 3. We can simplify this b sub 1, or we can rewrite 3 plus square root of 2, and b sub 2 will be positive 3 minus square root of 2. So these are now our final answers. Solving quadratic equations by completing the squares. Our next problem, we have 4b squared minus 8b equals to 32. Okay. So first, we need to cancel out the numerical exponent of our first term. So we need to divide both sides of the equation by 4. Okay. So 4b squared times 1 over 4, that will be 4b squared divided by 4. And negative 8b times 1 over 4, that will be negative 8b all over 4. This will be equal to 32 times 1 over 4, that is 32 divided by 4. So 4 divided by 4, we can cancel this out. This is equal to 1. And 8 divided by 2, this will be equal to positive 2. 32 divided by 4, this is 8. Okay. So 1 multiplied by b squared, this is equal to b squared minus 2 times b, that is 2b, and this will be equal to positive 8. Okay, we can now complete the square. Okay, we have here b squared minus 2b, and then we will add here a third term. Okay, so this will be plus, the third term will be a fraction. The numerator will be the numerical coefficient of our second term, disregarding the sign, so that will be 2. And then the denominator will be the constant number 2. Now we have to raise this to the power of 2. Okay. Now whatever is added on the left side must also be added on the right side. So we have here 8 plus 2 over 2 raised to the power of 2. So we have here b squared minus 2b plus 2 divided by 2 is 1 raised to the power of 2, that still is equal to 1. So this will be 8 plus 1. This is now a perfect square. So let's factor this out. The factor or the square root of b squared is b. Since this is negative, this will also be minus. And the square root of 1 is 1. And then we are going to raise this quantity to the power of 2 since this is a perfect square. And we have here positive 9. Now, to remove this power of 2, we need to get the square root of both sides of the equation. So we will have here the square root of b minus 1. So this will be the square root of b minus 1 raised to the power of 2 equals to, okay, let's check. So this will be equal to 9. Okay, equal to the square root of 9. So the square root of b minus 1 raised to the power of 2, this will now be b minus 1, and this will be plus minus 3. So to solve for b, we need to transpose negative 1 to the other side. So just transpose that to the other side. What will be left on the left side will now only be b, and this will be equal to plus minus 3. If we transpose negative, this will change sign. This will now become positive 1. Okay, so our b sub 1 now will be the positive 3. So this is positive 3 plus 1. Our b sub 2 will be the minus 3. So this is minus 3 plus 1. So b sub 1 here is 3 plus 1. That is 4. And b sub 2 will be negative 3 plus 1, negative 2. These are now our final answers. Solving quadratic equations by completing the squares. Our next problem, we have x squared plus 5x minus 39 all over 4 equals to 0. So to solve this quadratic equation by completing the squares, first we need to make sure that there is no numerical coefficient before our first term. So since there is none, we can proceed. And then next we need to transpose the third term to the right side because we are going to make here a new term. Okay, so transpose this to the right side. Transposing, what will be left on the left side will now only be x squared plus 5x equals to, if we transpose negative 39 all over 4, this will change its sign, this will become positive. So this will now be positive 39 all over 4. And then we will have here a third term. We are going to add the third term. So adding, we will have plus, our third term will be a fraction. So the numerator will be the numerical coefficient of the second term, disregarding the sign. So this will be positive 5 and divided by a constant number 2. And then raise this term to the power of 2. Now take note, whatever is added on the left should also be added on the right side. So we will also have here 5 all over 2 raised to the power of 2. So we have here x squared plus 5x plus 5 raised to the power of 2, that will be 25, and 2 raised to the power of 2 is 4. And we have here 39 all over 4 plus 25 over 4. Okay, now x squared plus 5x plus 25 all over 4 is a perfect square. So we can factor this out and raise the factor to the power of 2. Okay, so factor x squared, so its square root will be x. And since this is positive, this will also be plus, and the factor or the square root of 25 all over 4 will be 5 all over 2. So the quantity of x plus 5 over 2 raised to the power of 2. This is our perfect square. And then we are going to add the terms on the right. So 4 plus, so since our denominator is the same, we will just copy that and then add the numerators. So 39 all over, so 39 plus 25, this will give us positive 64. So to remove the square sign here, we are going to get the square root of both sides. So this will be the square root, and this will be also the square root on the right. So on the left will be the square root of the quantity of x plus 5 over 2 raised to the power of 2 equals to the square root of 64 all over 4. So that will be 64 all over 4. So the square root of the quantity of x plus 5 over 2 raised to the power of 2 will now be x plus 5 over 2. This will be equal to the square root of 64 all over 4. Okay, so this will be plus minus 8 all over 2. Okay, to find for x, we need to transpose positive 5 over 2 to the other side. So we need to transpose this to the other side. So our x now will be x is equal to plus minus 8 over 2. If we transpose this, it will change sign. So from positive, this will become negative 5 over 2. Our x sub 1 will be the plus. Okay, so we have here plus 8 over 2 minus 5 over 2. And our x sub 2 will be equal to the minus, so this will be minus 8 over 2 minus 5 over 2. So since we have the same denominator, we will just, okay, this is x sub 1. X sub 1. Now since we have the same denominator, copy the denominator and then subtract the numerator. So 8 minus 5 is 3, or this would be 1 and 1/2. Our x sub 2 here, copy the denominator, which is 2, and subtract negative 8 minus 5. This will be negative 13, or this will be negative, okay, this will be 6, negative 6 and 1/2. So therefore, x sub 1 equals to positive 1 and 1/2, and x sub 2 equals to negative 6 and 1/2 are our final answers. Solving quadratic equations by completing the squares. Next problem. We have y squared plus 9y plus 45 all over 4 equals to 0. So to solve this quadratic equation by completing the square, first we need to check if there is a numerical coefficient before our first term. So since there is none, we can now proceed. Now, we need to transpose positive 45 all over 4 to the right side so that there will only be 2 terms left on the left side. So we need to transpose that to the right. We will have here y squared plus 9y equals 2. If we transpose positive to the other side, this will change sign. It will become negative. So this will now be negative 45 all over 4. Okay, and then we are going to add here a third term to make it a complete square. So we are going to add, so the third term will be a fraction, and the numerator will be the numerical coefficient of our second term. So this is 9. Divide this by a constant number, and that is positive 2. And raise the term to this power of 2. So we have here y squared plus 9y plus 9 raised to the power of 2, that will be 81, and 2 raised to the power of 2 is 4. Whatever is added on the left side must also be added on the right side. So this will be plus 9 over 2 squared. So negative 5 over 4 plus 81 all over 4. So y squared plus 9y plus 81 over 4 is a perfect square. So we can have this. Okay, so the factor of y squared, or the square root of y squared, is y. And then since this is positive, this will also be plus. And the square root of 81 all over 4 will be 9 all over 2. And then you raise this term to the power of 2. And this will be equal to, now since they have the same denominator, just copy the denominator, and then negative 45 plus 81. Okay, so negative 45 plus 81, this will give us positive 36. So this will be positive 36 all over 4. Now to remove the square sign here, we need to get the square root of both sides of the equation. So we will have here the square root of and the square root of. Okay, so on the left side we will have the square root of the quantity of y plus 9 over 2 raised to the power of 2. And we will have here the square root of 36 all over 4. Okay, so the square root now of the quantity of y plus 9 over 2 raised to the power of 2, this will be equal to y plus, okay, let's check, that's y plus 9 over 2, and this will be equal to the square root of 36 over 4. This will be plus minus 6 all over 2. So to solve for y now, we need to transpose positive 9 over 2 to the other side. So we need to transpose this to the other side. What will be left on the left side will now be y equals 2 plus minus 6 all over 2. If we transpose plus minus 9 over 2, or rather plus 9 over 2, this will change sign. This will now become negative 9 over 2. So our y sub 1 here will be plus 6 over 2 minus 9 over 2. Our y sub 2 will be the minus 6 over 2 minus 9 over 2. So our y sub 1 will be, copy the denominator, which is 2, 6 minus 9, that is negative 3. And this will also be negative 1 and 1/2. Our y sub 2 will be, copy the denominator, which is 2, and then negative 6 minus 9, this will be negative 15 over 2, or negative 7 and 1 over 2. So therefore, y sub 1 equals to negative 1 and 1 over 2, and y sub 2 equals to negative 7 and 1 over 2. They are our final answers. Solving quadratic equations by extracting square roots. Our first problem, we have b squared minus 64 equals to 0. So this is a quadratic equation because of the exponent 2, and we can extract the square root because 64 is a perfect square. So to find for the value of b, we first need to separate b squared and 64. So to separate them, we need to transpose negative 64 to the other side. So transposing, what will be left on the left side will be b squared. And if we transpose negative to the other side, this will change its sign. This will become positive 64. And then to find for the value of b, we need to extract the square roots. Okay, so we need to raise both sides of the equation to 1/2. So b squared raised to 1/2, 64 raised to 1/2. Okay. So the exponent here, the denominator of the exponents, this will be the equivalent of the roots. So since 2 is their root, this will be the square. So this will be the square root. Okay, our base is b squared, and the exponent here will be the numerator. So our numerator of our numerator here is 1, so that will be the exponent of b squared. So this will be b squared raised to 1. This is equal to, again, that is the square root, since this is 2, and our base is 64. And then this will be raised to the exponent of 1, since 1 is our numerator. So this will be 64 raised to 1. Now, this is now equal to b squared, and this is the square root of 64. Now the square root of b squared is b, and the square root of 64, there will be 2 roots, so we will have plus minus. The square root of 64 is plus minus 8. Okay, let us check if our answers are correct. So check. So for b equals to positive 8, and for b equals to negative 8. So we have here b squared minus 64 equals to 0, and also b squared minus 64 equals to 0. So our b here is positive 8 raised to 2 minus 64 equals to 0. And our b here, that is negative 8 raised to 2 minus 64 equals to 0. So positive 8 raised to 2 is 64 minus 64 equals to 0. And negative 8 raised to 2, that is also 64 minus 64 equals to 0. So 64 minus 64 is 0. So 0 is equal to 0. So our first value is correct. Okay. Our next value, 64 minus 64, this is also equal to 0, equal to 0. So our second value, which is b equals to negative 8, is also correct. So these are our final answers. Solving quadratic equations by extracting square roots. Our next problem is a squared equals to 256. So to extract the square root, so we will have here a squared. We are going to raise both sides of the equation by 1/2. So we are going to raise this by 1/2. Raised to 1/2. 256 raised to 1/2. So if we are going to raise this, the denominator here, this will be our root, and the numerator will be the exponent of the base. Okay, so this will be equal to the square root. Our base here will be a squared, and our numerator of the exponent, so this will be the exponent of the base, that is equal to 1. And this is also equal to the square root. Our base will be 256. Our exponent will be the numerator, and that is 1. So this will be a squared, the square root of a squared, equals to the square root of 256. The square root of a squared is equal to a, and we have here the square root of 256. There will be two roots, the positive and the negative. So this will be positive and negative, and the square root of 256 is 16. And now let us check if our answers are correct. So we are going to substitute a equals to positive 16, and also another a, which is negative 16. Our equation is a squared equals to 256. Another a squared equals to 256. So our a here is positive 16 raised to the power of 2. And this is 256. So we have here negative 16 raised to the power of 2 equals to 256. So 16 raised to 2 is 256, and this is equal to 256. Negative 16 raised to the power of 2, this will be positive 256 equals to positive 256. So therefore, our two answers are correct. Solving quadratic equations by extracting square roots. Our next problem, we have 16 y squared minus, or rather 16y squared is equal to positive 576. So to solve this, we first need to separate 16 from 16y squared. So we have here 16y squared equals to 576. So to separate 16 from 16y squared, divide both sides of the equation by 16. So we have 16 divided by 16. This will be equal to 1, so we can cancel this out. Okay. So what will be left here will be y squared. And then we have 576 divided by 16. This will give us positive 36. To solve for y, we need to extract the square roots of both sides of the equation. So to do this, we need to raise both sides of the equation by 1/2. So raise this to 1/2, raise to 1/2. So the denominator here will be the root of the equation. So since 2 is the root of y squared, this will be the square root. The same is true for 36. This is the square root. So our base is y squared. Its exponent will be the numerator. Its exponent here is 1. And here we have the base, which is 36. And the exponent is 1. So this will be the square root of y squared, and this is the square root of positive 36. The square root of y squared, that is positive y, and the square root of 36, we will have two values. We will have positive and negative 6. And then let us check. So we have here the first value, y equals to positive 6. And we have another value, y equals to negative 6. Our equation, we have 16 y squared equals to 576. And we have here negative, or rather, this will be 16 y squared equals to 576. So our y here is positive 6 raised to the power of 2 equals to 576. And we will have here 16. Our y is negative 6 raised to the power of 2. This will be equal to 576. So we have 16 multiplied by 36 equals to 576. And we have 16 negative 6 raised to 2, that is also positive 36, equals to 576. So 16 multiplied by 36, 576, equals to 576. And 16 times 36, 576, equals to 576. So therefore, our answers, which is y equals to positive 6 and y equals to negative 6, they are correct. Solving quadratic equations by extracting square roots. Our next problem, we have 49 b squared is equal to positive 17689, or positive 17,689. So to solve for this, first we need to cancel out 49 from 49b squared. So to do this, we need to divide both sides of the equation by 49. So dividing, we will have 49 b squared all over 49. This will be equal to 17,689 divided by 49. So 49 divided by 49, okay, we can cancel this out, that is equal to 1. So what will be left on the left side will be b squared. And then we have 17,689 divided by 49. That will give us 361. To find for b, we need to extract the square root of both sides of the equation. So to extract the square root, first we need to raise both sides of the equation by 1/2. Raise this to 1/2. Okay. Now, since the denominator of the exponent is 2, this will be the square root. Okay, so the square root on the left, and the same is true on the right side, also the square root. So our base here is b squared. The exponent here will be the numerator, and the numerator is 1, so that will be b squared raised to 1. Our base here is 361. The exponent is also 1, so 361 raised to 1. This will be the square root of b squared equals to the square root of 361. Now, the square root of b squared, this will be positive b, And we have here the square root of 361. We will have two values, the positive and the negative. So 361, the square root of 361 is 19. Now let us check if the answers are correct. So first, B is positive 19. And we also have B, which is negative 19. So our equation will be 49. Our B here is positive 19 squared equals to 17,689. So for here, we also have 49 times negative 19 raised to 2 equals to 17,689. So we have here 49 and we have 19 squared. This will be 361 equals to 17,689. So this will be 49 negative 19 raised to 2, that will be 361, and this is 17,689. 49 multiplied by 361, this is 17,689. So 14,689. Again, this is 17,689, also equal to 17,689. So therefore, our answers for B, which are positive 19 and negative 19, are correct. Solving quadratic equations by extracting square roots. Our next problem, we have 16x squared minus 64 equals to 0. To solve for the value of x, first we need to separate negative 64 to the other side. So to do this, we need to transpose negative 64 to the other side. So transposing, what will be left on the left side will only be positive 16x squared. So if we transpose negative, this will change sign. From negative, this will become positive 64. And next, we have to cancel out 16 from 16x squared. So to do this, we need to divide both sides of the equation by 16. So 16x squared divided by 16 and 64 divided by 16. So dividing 16 divided by 16, we can cancel this out since this will be equal to positive 1. So 1 multiplied by x squared, this will give us x squared. And then we have 64 divided by 16, this will be equal to 4. And to solve for x, we need to extract the square roots. So extracting, we are going to raise both sides of the equation by 1/2. So since the denominator of our exponent, they have 2 as denominator, this will be equivalent to the square root. So this will also be the square root. And then our base here is x squared, and its exponent will be the numerator. So its exponent will be 1. And our base here is 4, its exponent will be 1. The square root of x squared, that will give us positive x, and the square root of positive 4, there will be 2 values, positive and negative, and this will be 2. Let us now check if our answers are correct. So our first value of x is positive 2. The second value of x is negative 2. Our equation is 16x squared minus 64 equals to 0. We have here also 16x squared minus 64 equals to 0. So our value for x is positive 2. This will be squared minus 64 equals to 0. So we will also have here 16. Our value of x here is negative 2 raised to the power of 2 minus 64 equals to 0. So we will have here 16, 2 raised to the power of 2, that is positive 4, minus 64, this will be 0. And 16 multiplied by negative 2 raised to the power of 2, that will be positive 4, minus 64, and this will be equal to 0. So 16 times 4, that is 64, minus 64, this is equal to 0. So 16 times 4, still 64, minus 64 equals to 0. So 0 equals 0, 0 equals to 0. So therefore, our values for x, which are positive 2 and negative 2, they are correct. Solving quadratic equation by extracting square roots. Our next problem, we have positive 49 d squared minus 12,544 equals to 0. So to solve for the value of d, first we need to transpose negative 12,544. So we need to transpose this to the other side. So transposing, what will be left on the left side will only be 49 d squared. And if we transpose negative to the other side, this will become positive 12,544. And to find for the value of d, we need to cancel out 49 from 49 d squared. So to cancel out, we are going to divide both sides of the equation by 49. So 12,544 divided by 49. So 49 divided by 49, we can cancel this out since this is equal to 1. And 1 multiplied by d squared, this is positive d squared. And we have here 12,544 divided by 49. This will give us positive 256. To find for the value of d, we need to extract these square roots. So to extract the square roots, let us raise both sides of the equation to 1 over 2. So raise both sides of the equation by 1 over 2. Now, since both of the denominators of the exponents is 2, this is equivalent to the square root. So we have here the square root on the left and the square root on the right. And the base here will be d squared. The exponent will be the numerator. So the numerator is 1. And we have here 256. The exponent is also 1. So this will be the square root of d squared, and the square root of d squared is d. And then the square root of 256, we will have two values that will be positive and negative. And that will be plus minus 16. Let us now check if our answers for d are correct. Our equation is 49d squared minus 12,544 equals to 0. So we have here 49d squared. Okay, let us erase that. Let us rewrite so that it will fit. Okay. So this will be 49d squared minus 12,544 equals to 0. And 49d squared minus 12,544 equals to 0. So our D here, 49 multiplied by 16, positive 16, raised to 2 minus 12,544 equals to 0. So 49 multiplied by negative 16 raised to 2 minus 12,544 equals to 0. So we have here 16 raised to the power of 2, that will give us 256. So this will be 49 times 256 minus 12,544 equals to 0. And this will also be 49, negative 16 raised to the power of 2, that will also be 256 positive, minus 12,544 equals to 0. Now, 49 times 256, that will also be 12,544. So minus 12,544 equals to 0. And this will be 12,544 minus 12,544 equals to 0. So this is 0 equals to 0. 0 equals to 0. So therefore, our values for x, which is positive 16, and x negative 16, they are correct. Solving quadratic equation by extracting square roots. Our next problem, we have the quantity of a minus 6 raised to the power of 2 equals to positive 196. To solve this, we first have to extract the square roots of both sides. So to do this, we are going to raise both sides of the equation by 1 over 2. So this will be taken as one quantity. So this will be a minus 6 raised to 2. And then we are going to raise this to exponent 1 over 2. So same on the right side of the equation, we will have 196. And we are going to raise this to the power of 1 over 2. Okay. So again, since the denominator is 2 for the exponent, this will be equivalent to the square root. So we will also have here the square root. So this will be the square root of a minus 6 raised to 2, and this will be raised to the exponent of 1, which is the numerator. So we will have here 196 raised to 1. So this will be equal to, since this is 2 times 1, that would still be equal to 2. So we will have here a minus 6 raised to 2. And this will be the square root. So the square root of 196 will be, okay, so later we will write the value. But here, so let's get the square root first. The square root of the quantity of a minus 6 raised to the power of 2. So this will be equal to a minus 6. And the square root of 196 will be plus minus 14. So if we are going to get for the value of a, we need to transpose negative 6 to the other side. So we will have here two values for a. So our first value for a will be the positive 14. So we are going to use first positive 14. And if we transpose negative, this will be positive 6. So this will be our a sub 1. So our a sub 1 will be positive 20. Our a sub 2. So our a sub 2 will be negative 14. And then we will have positive 6. So our a sub 2 will be equal to negative 14 plus 6. This will give us negative 8. Okay, so this will give us negative 8. So positive 20 and negative 8. Let us check if our answers are correct. So our equation, we have the quantity of a minus 6 raised to 2 equals to 196. So for our first value of a, which is 20, so 20 minus 6 raised to 2 equals to 196. So 20 minus 6 is 14. And 14 raised to the power of 2. So we have here 14 raised to the power of 2. That will give us positive 196. So our positive 20 is correct. How about, okay, let's check the other value, which is negative 8. Okay, so let us try negative 8. So again, this will be, okay, let's change the color of that. Okay, let's change that to what? So this will be the quantity of a minus 6 raised to 2 equals to 196. So our a here will be negative 8 minus 6 raised to the power of 2 equals to 196. Now negative 8 minus 6, that is negative 14 raised to the power of 2, 196. So negative 14 raised to the power of 2, that will be equal to 196. So again, the value for x, which is negative 8, is also correct. Solving quadratic equations by extracting square roots. Our next problem, we have the quantity of b plus 8 raised to the power of 2 equals to 225. So to find for the value b, first we need to extract the square roots of both sides of the equation. So to do this, we are going to raise both sides of the equation to 1 over 2. So this will be b plus 8 raised to the power of 2. So we are going to take that as 1 unit, and then we are going to raise it by 1 over 2. Okay, same is true on the right side. So we will have here 225, and we need to raise this to 1/2. Okay. Now, since the denominator of the two exponents is 2, this will be equal to the square root. So the square root. And then our base on the left will be the quantity of b plus 8 raised to the power of 2. And this will be raised to the exponent. Okay, so the exponent here will be the numerator. So the numerator here is 1. And we will also have here the square root of the base, which is 225. And this will also be raised to the numerator, which is 1. So raise this to 1. Now, since this is 2 multiplied by 1, that would still be 2. So this will be the square root of the quantity of b plus 8 raised to 2. And this will also be the square root of 225. Okay. Okay, so we have here the square root of b plus 8 raised to 2 equals to the square root of 225. Now the square root of b plus 8 raised to 2, so 2 divided by 2, that would be b plus 8 now. And the square root here of 225, that will give us plus minus 15. So to solve for b, we need to transpose positive 8 to the other side. So we are going to transpose this to the other side. So we will have two values for b. Our first value for b will be, first we are going to use positive 15. Now if we transpose positive, it will change sign. This will be negative 8. So this will be our b1. So our b1 will be 15 minus 8, that will be positive 7. And for our b2, that will be negative 15 minus 8. So b2 here will be equal to negative 23. And then let us check if our answers are correct. So our equation is this: b plus 8 raised to the power of 2, and that is equal to 225. So our first b, we have positive 7. So 7 plus 8 raised to the power of 2 equals to 225. So we will have here 15 raised to 2 equals to 225. 15 raised to 2, that is 225. So the first value for b, which is positive 8, which is rather positive 7, is correct. Okay, so this is correct. Let's check negative 23. So we have here b. Okay, let's erase that. So we have here b plus 8 raised to 2 equals to 225. Our b here will be negative 23 plus 8 raised to 2 equals to 225, and negative 23 plus 8, that will be negative 15 raised to 2 equals to 225. And negative 15 raised to 2, that would also be 225. So therefore, b equals to negative 23 is also correct. Solving quadratic equation by extracting square roots. Our next problem, we have x all over 50. This will be equal to 2 all over x. So to solve for the value of x, first we need to cross multiply the equation. So this means that x will be multiplied by x, so this will give us x squared. And 50 multiplied by 2, this will give us 100. So to solve for x, we need to extract the square roots. So to extract the square roots, we are going to raise both sides of the equation by 1 over 2. Now, since the denominators is the same, which is 2, this is equivalent to the square root. So we will have 2 square roots, and our base here will be x squared. Its exponent will be the numerator, and that is positive 1. So our base here will be 100. The exponent will be the numerator, which is positive 1. So x squared raised to 1, that is still x squared. So the square root of x squared will be equal to x. And the square root of 100 will be plus minus 10. Let us check if our answers are correct. So our equation will be x all over 50 equals to 2 over x. So let us first use positive 10. So 10 divided by 50, and this will be 2 divided by 10. So 10 divided by 50, that will be 1 all over 5. And this will be 1 over 5. So our x, which is positive 10, is correct. Let us now try x negative 10. So this will be negative 10 all over 50. This is equal to 2 all over 10. So this will be negative 1 over 5 and negative 1 over 5. So therefore x equals to negative 10 is also correct. And these are now our final answers for the problem solving quadratic equation by extracting the square roots. Solving quadratic equations by extracting square roots. Our next problem, we have y all over 9. This is equal to 4 all over y. Now, to find for the value of y, we first need to cross multiply the given. So this means that y multiplied by y, this will give us y squared equals to 9 multiplied by 4, that is positive 36. And to find for y, we need to extract the square roots on both sides of the equation. So to do this, we are going to raise this to 1/2. 36 will be raised to 1/2. And since the denominator of the exponent is 2, this will be equal to the square root and the square root. So we have here y raised to the power of 2. Its exponent will be the numerator, and that is 1. So 36 is the base. Its exponent will be the numerator, and that is 1. So y raised to 2 multiplied by 1, that is still y squared. So the square root of y squared is positive y. And 36, or the square root of 36, this will be plus minus 6. And let us check if our answers are correct. So our first value for y is positive 6. So our equation will be y all over 9 equals to 4 all over y. So our y here is positive 6 all over 9, and this will be 4 all over 6. So we can simplify this 6 and 9. This will be 2 over 3, since 3 is common between them. And 2 and 6, 2 is common between them, so 2 divided by 2, 4 is 2, and 6 divided by 2 is 3. So therefore, y equals to positive 6 is correct. Let us now check y equals to negative 6. So this will be negative 6 all over 9 and 4 all over negative 6. So this will be negative 6 divided by 3 is 2, 9 divided by 3 is 3. And this will be 2, 4 divided by 2, that is 2. So this is now negative all over 6 divided by 2 is 3. So therefore, y equals to negative 6 is also correct. Our next problem, we have positive 64x squared minus 56x plus 10 equals to 0. Looking at the equation, we can still simplify this since 2 is common among the three terms. So we are going to divide both sides of the equation by 2. So 64x squared divided by 2, this will give us positive 32x squared, and negative 56x divided by 2, this will give us negative 28x, and then positive 10 divided by 2, this will give us positive 5 equals to 0. Okay, so this is now our quadratic equation. Now, since we have here a numerical value before x squared, so we are going to factor out first the first term. Okay, so this will be equal to 0. Now, the factors. What will be the factors of 32x squared? Okay, let us use 8x and 4x. Okay, so we will have here 8x, and this will be multiplied by 4x. Okay, so 8 times 4 is 32. And then for our third term is positive 5. Now, our third term is positive, and our second term is negative. So it is safe to say that our factors here must be both negative. Okay, since negative multiplied by negative, that is positive. Okay, and the factors of positive 5 will be negative 5 and negative 1. Let us check if our factors are correct. Okay, so we are going to get the product of the outside terms. 8x multiplied by negative 1, this will be negative 8x. And then 4x multiplied by negative 5, that is negative 20x. Now, negative 8x minus 20x is negative 28x. Therefore, this is the same as our second term, so these factors are correct. They are the ones that we are going to use. So we can now erase this. Okay, so let us now solve for the value of x. So we have here 8x minus 5 equals to 0. So to solve for the value of x, first we need to transpose negative 5 to the other side. Okay, so transpose that. What will be left on the left side will only be positive 8x. And if we transpose negative, this will change sign. This will become positive 5. To solve for the value of x, we need to cancel out 8. So divide both sides of the equation by 8. Now, 8 divided by 8, this will be equal to 1. And 1 multiplied by x, this is equal to positive x. And 5 over 8. So we cannot simplify this anymore. So this is our x sub 1. To solve for our x sub 2, we have here 4x minus 1 equals to 0. So to solve for x, we need to transpose negative 1 to the other side. Okay, so transpose that to the other side. So what will be left on the left side will only be positive 4x. And if we transpose negative 1, this will change sign. This will become positive 1. And to solve for x, we need to cancel out 4. So to cancel 4, divide both sides of the equation by 4. Now, 4 divided by 4, this will be equal to 1. We can cancel this out. That is equal to 1. So 1 multiplied by x, this is equal to x. And 1 over 4. So this will be x sub 2. So our final answer is x sub 1 equals to 5 over 8. And x sub 2 equals to 1 over 4. Our next problem, we have 7b squared minus 4b minus 11 equals to 0. We cannot simplify this anymore, so this will be our final quadratic equation. And since we have here a numerical coefficient, we will start with our first term. Okay, so there will be two sets here, and this is equal to 0. Now, the factors of 7b squared, this will be 7b multiplied by positive b. So 7b times positive b is 7b squared. And then we will factor out our third term. So our third term here is negative 11. Now, since this is negative and this is also negative, our factors will be negative and positive. So the factors of 11, it is only 11 and 1. Okay. And then let us check if these factors are correct. We are going to get the sum of the product of the outside terms. So our outside term is positive 1 and 7b. So 7b times positive 1, that is 7b. And then our inside terms, we have b multiplied by negative 11. This is negative 11b. So 7b minus 11b, that is equal to negative 4b. So our negative 4b is equal to our second term. So therefore, these are the final factors that we are going to use. So we can erase this one. Okay, let's erase this. We will then find for the values of b. Okay, so we have here 7b minus 11 equals to 0. So to find for the value of b, transpose negative 11 to the other side. So we are going to transpose negative 11 to the other side. So what will be left on the left side will be 7b. And if we transpose negative 11, it will change its sign. It will become positive 11. So from negative, it changes to positive. And to find for b, we need to cancel out 7. So divide both sides of the equation by 7. So 7 divided by 7, this can be cancelled out. This will be equal to 1. And 1 multiplied by b, this is equal to positive b. And this is 11 over 7. We cannot cancel this out, so this will be our b sub 1. And let us find the value of b sub 2. So we have here b plus 1 equals to 0. So to find for the value of b, we are going to transpose positive 1 to the other side. So transpose that to the other side. Okay. So if we are going to transpose, what will be left on the left side will be positive b. And if we transpose this, it will change sign. So from positive, this will become negative 1. So this is our b sub 2. So therefore, our b sub 1, okay, but we can still simplify this. Okay, so 11 over 7, this can be simplified as 1 and 4 over 7. So b1 is equal to 1 and 4 over 7. b2 equals to negative 1. They are our final answers. Our next problem, we have positive 5y squared minus 2y minus 7 equals to 0. Since we cannot simplify this anymore, so this will be our final quadratic equation. Now, there is a numerical expression or a numerical coefficient on our first term, so we are going to start our factoring on our first term. So there will be two sets. Okay, this will be equal to 0. The factors of 5y squared. So the factors of 5y squared will be 5 multiplied by y, and we will have here y. So 5y multiplied by y, that is 5y squared. And then we are going to factor out negative 7. Now, since this is negative and our second term is also negative, so the factors of 7 or negative 7 will be negative 7, and we will have here positive 1. Now let us check if our factors are correct. So we will get the product of our outside terms. So the product of our outside terms will be 5y multiplied by positive 1, that is 5y. And then we have y multiplied by negative 7. These are our inner terms. Okay, so we have negative 7y. So 5y minus 7y, this is negative 2y. So negative 2y here is equal to our second term, which is negative 2y. So we are now sure that this factor will be the final factors that we are going to use. Okay. And then we are now going to find for the value of y. We have here 5y minus 7 equals to 0. And we also have y plus 1 equals to 0. So to find for y, we need to transpose negative 7. So to transpose negative 7, what will be left? On the left side will only be 5y. And if we transpose negative, this will become positive. So the sign will change. So instead of negative, this will now become positive. And to find for y, we need to cancel out 5. So divide both sides of the equation by 5. So 5 divided by 5, this will be equal to 1. So cancel this out. So 1 multiplied by y, this is equal to y. And 7 over 5, let's simplify this, or let's convert this into an improper fraction. So this will be 1 and 2 over 5. So this is our y sub 1. Now let us find the value for y sub 2. So to find for y sub 2, we need to transpose positive 1 to the other side. If we transpose positive 1, what will be left on the left side will be positive y. And if we change positive 1, if we transpose positive 1, it will change its sign. It will become negative 1. This is our y sub 2. So therefore, y sub 1 equals to 1 and 2 over 5, and y sub 2 equals to negative 1. They are our final answers. Our next problem, we will have 8y squared minus 42y plus 27 equals to 0. Okay. So we cannot simplify this anymore, so this will be our final quadratic equation. Now, we have here a numerical coefficient before our y squared, so we will start our factoring with our first term. So we will have here 2 sets equals to 0. So the factor of 8y squared. Okay, so we are going to factor out first 8y squared. So its factors will be 4y multiplied by 2y. Okay, let us check if it is correct. 4y multiplied by 2y, that is equal to 8y squared. Okay, and the next that we are going to factor out will be the last term, or positive 27. Now, since this is positive and our second term is negative, we can be sure that the sign of the factors of positive 27 will all be negative. So negative multiplied by negative, that is equal to positive. Okay, and the factors of positive 27, let's try negative 3 and negative 9. Okay, now let us check if our factors are correct. Okay, we are going to multiply all the outside terms. So negative 9 multiplied by positive 4y, this will give us negative 36y. And we will multiply all the inside terms. Okay, So positive 2y multiplied by negative 3, this will be negative 6y. So negative 36y minus 6y, this is equal to negative 42y. Therefore, our negative 42y here is equal to our second term. So these are now our final factors. Okay. We will then find for the values of y. Okay. So our first factor here is 4y minus 3 and equate this to 0. And our second factor is 2y minus 9 equals to 0. So to find for the value of y, first we need to transpose negative 3 to the other side. Okay. After transposing, what will be left on the left side will only be 4y. If we transpose negative to the other side, this will change sign. So from negative, it will become positive. And to find for y, we need to cancel out 4. So to cancel out 4, divide both sides of the equation by 4. 4 divided by 4, we can cancel this out. This will be equal to 1. And 1 multiplied by y, that is equal to y. So 3 over 4. So we cannot simplify this anymore, so this will be y sub 1. Now to find for y sub 2, we need to transpose negative 9 to the other side. Okay. After transposing, what will be left on the left side will be 2y. And if we transpose negative, this will become positive. So this will be positive 9. To find for the value of y, we need to cancel out 2. So to cancel out 2, divide both sides of the equation by 2. Okay. So 2 divided by 2, this is equal to 1. So we can cancel that out. 1 multiplied by y, that is positive y. And 9 over 2, okay, we can change this into improper fractions, so this will give us 4 and 1 over 2. So this will be our y sub 2. And these are now our final answers. Our next problem, we have 4 multiplied by the quantity of 3x squared plus 2 equals to positive 35x. Okay, so first we are going to perform the operation. So 4 multiplied by 3x squared, so this will be 12x squared, and 4 multiplied by positive 2, this will be positive 8 equals to 35x. Okay, now we need to transpose positive 35x to the left side so that we will be of the form quadratic equation. Okay, so transposing, we will have here 12x squared, and if we transpose positive 35, it will change its sign. This will become negative 35x plus 8 equals to 0. Okay, so we cannot simplify this anymore, and there is a numerical coefficient on our first term, so we are going to start our factoring with our first term. Okay, so by trial and error, the factors of 12x squared that we are going to use will be 4x and positive 3x. Okay, and then let us factor out positive 8. So positive 8. Now since this is positive and this is negative, we can say that the factors of positive 8 will be negative and negative. And again, by trial and error, we will use negative 1 and negative 8. Let us check if our factors are correct. So we will multiply all the outside terms. negative 8 multiplied by 4x, negative 32x. And positive 3x multiplied by negative 1. These are the inside terms. This is negative 3x. So negative 32x minus 3x, negative 35x. Okay, so negative 35x is equal to our second term, which is also negative 35x. So we can say that these are our correct factors. Okay, we can erase this one, and we can now proceed to finding the values of x. Okay, let's erase this first. So our first factor, we have 4x minus 1 equals to 0. And our second factors, we have 3x minus 8 equals to 0. Now, to solve for the value of x, first we need to transpose negative 1 to the other side. So transpose that to the other side. Now, what will be left on the left side will only be 4x. And if we transpose negative 1, this will change sign. This will become positive 2. To find for the value of x, we need to cancel out 4. So to cancel 4, divide both sides of the equation by 4. So 4 divided by 4, this will be equal to 1. And 1 multiplied by x, that is equal to x. And we can simplify this. This will be 1 over 2. So our x sub 2 is equal to 1/2. Now to find for, or rather this is not x sub 2, but this is x sub 1. So to find for x sub 2, first we need to transpose negative 8 to the other side. Okay. So after transposing, what will be left on the left side will now be 3x. If we transpose negative to the other side, it will change sign. It will become positive. To find for x, we need to cancel out 3. So 3x divided by 3 and 8 divided by 3. And then we can cancel out 3 divided by 3. This is positive 1. And 1 multiplied by x, this is equal to x. And we can change this to mixed fractions. So this will be 2 and 2 over 3. This is our x sub 2. So therefore, x sub 1 equals to 1/2. And x sub 2 equals to 2 and 2/3. They are our final answers.